So students, we are continuing with the same chapter, number systems, the first chapter of CBSE Standard 9 Maths. And today we'll see in brief a gist of what all is included in number systems, the chapter, what all is included. So if you go through my other videos, earlier videos, in my other videos I've explained and also solved problems regarding the whatever is made up under number systems. So we'll do a small brief gist of what is there. So as you all know, the number systems is made up of all numbers which are real numbers, like we know what are the numbers. So already I have explained to you in the other chapters also, in the other videos also. We'll see what all is coming under real numbers. Okay. So under number systems, this chapter, it includes real numbers. So A, real numbers. Now what all is included under real numbers? So what all makes up real numbers? So we have seen earlier also, first is natural numbers. Natural numbers. Second, whole numbers. Third, integers. Fourth, rational numbers. Rational numbers. And fifth, irrational numbers. So all of these are making up the real numbers: natural numbers, whole numbers, integers, rational and irrational numbers. Now the chapter number systems also, this is the basic, the different types of numbers. Then what is included under this chapter is a little bit of the the expansion of these, like the operations, how the number line, the different numbers, all the real numbers. First is how they are placed on the number line. So on a number line, where all will these natural numbers have their location, we can say, where they are located on the number line. That is one. Then you have the decimal expansion of the real numbers. Okay, decimal expansion. Then you have operations on real numbers. On operations on real numbers includes rationalization of the numbers also. So I have done in some other videos. I will be doing more videos for each of these subtopics. Then finally you have laws of exponents for natural numbers. Laws of exponents are for natural numbers, because negative numbers and zero, we cannot have exponents for that. You got it? So only the positive numbers. What are the natural numbers? That are included under this subheading of laws of exponents for natural numbers. So I'll rub this out and I'll write down what all is there in that. So we have seen the real numbers. The next subtopic is real numbers and their decimal expansions. So second is real numbers and their decimal expansions. So what are decimal expansions? Like you have rational numbers, we will take as 1 upon 2 example. Okay, 1 upon 2. So what will be the decimal expansion of this? So here this is equal to 1 is being divided by 2. Okay, we have to divide 1 upon 2, we have to divide to get the decimal expansion of this. The decimal expansion is the answer of this. 1 divided by 1 is smaller than 2. So we have to bring a 0. First time we are bringing a 0, here we will have to put a 0 and a decimal point. Okay, now this is 10 and this is 2. So 5 is 2 5 is 10. So here this is a terminating number 1 upon 2, a terminating rational number. So under decimal expansions we get to know whether the number is terminating or non-terminating. And again, sometimes if it is non-terminating, it can be repeating or non-repeating also. So a small example of this for decimal real numbers and the decimal expansions 1 upon 2. So this is a terminating, this is terminating. Terminating, because when we divided 1 by 2 we got 0.5, the decimal expansion answer, and the remainder is 0, so it is terminated. Now again I will show you non-terminating. One example of non-terminating number. So we'll take this 10 upon 3, the example. Example 10 upon 3. So we'll do the decimal expansion of this. Here 10 is being divided by 3. So 3 3s are 9 minus. Again the remainder is coming to 1. 1 is smaller than 3. So again we bring a 0. First time we are bringing a 0. Here we will put a decimal point. Okay. Then again 3 3s are 9. Again remainder is 1. Again 0. Again it will be 3 3s are 9. So this will go on. Every time the remainder will be 1, and then we bring a 0 and we divide that 10 by 3. Again the remainder will be 1. So 3.3333 it will go. So this is a non-terminating. This decimal expansion is non-terminating. This is an example of non-terminating but repeating, because this 3 is going on repeating. 3.33. So this is a non-terminating but repeating. Non-terminating repeating type of example for decimal expansion, non-terminating, repeating. Then we'll see the next, wherein it will be non-terminating as well as non-repeating. Both will be there. Non-terminating, non-repeating. Like 11 by 3. We'll try 11 by 3. Okay. So that is equal to 11 divided by 3. 11 is divided by 3. So 3 3s are 9 minus remainder is 2. We bring a 0. Here will be a decimal point. 3 6 are 18 minus, no, this also will be a repeating. This also is a repeating. We will have to try with some other example. So this is a repeating. We'll try with some other example. So we'll try with 17 divided by 7. Let's see what we get here. So that is equal to 17 divided by 7. 7 2s are 14 minus 3. The remainder is, we bring a 0 decimal point. 7 4s are 28 minus 2 is remainder. We bring here 0. 7 2s are 14. Remainder is 6. We bring a 0. 7 8s are 56. 7 8s are 56 minus 4. So we get 40. 7 5s are 35. Okay, so here the remainder will be 5. Okay, I am continuing from here. Then again divided by 7, the same 7. Again it will be 7 7s are 49 minus 1. So every time some other number is coming under this type of, so this is an example of non-terminating as well as non-repeating. No number is getting repeated in any pattern, under any pattern. So this is an example of non-terminating non-repeating non-repeating. So when the decimal expansion of any real number is non-terminating, non-repeating, then we can say that this is an irrational number. So 17 upon 7 is an irrational number because the property, it satisfies the property of an irrational. Whereas we have seen the earlier two, where it was 1 upon 2, that was terminating. So that is a rational number, terminating. Then again we did 10 upon 3. So there we got the answer 3.333. So that 333 is repeating. So that is non-terminating but repeating. That also proves that it is a rational number. So here we get to know whether a number is a rational number or an irrational number by using this property, real number and the decimal expansions. Okay, I'll rub this out. Then the next subtopic under number systems is real numbers representing real numbers on the number line. I have already shown this representation, one example in my other video. Later on I will solve more of these. We will do some more examples pertaining to representing the different numbers on the number line. Okay. Then next we have is operations. Operations on real numbers. Operations on real numbers. Operations on real numbers. So this operations on real numbers includes rationalization of the numbers. So rationalization will come under this subtopic, rationalization. We'll solve more of this in my next video. Then you have the last subtopic is laws of exponents. Laws of exponents for natural numbers. For natural numbers. So there are a few laws which have to be used to get to find out the problems under this chapter, laws of exponents for natural numbers. Okay, so all of this what I have shown you today in this video make up the different subtopics under number systems in all for the 9th standard maths syllabus of CBSE board. Okay, so we'll complete this now.